Hear me very carefully. I'm saying all this to help you when you're struggling in solving. Don't stress your mind too hard. This video is going to make a sense in solving and everything will fall in place. And coming to the point which is most important, that is the topic today is the principal conjunctive normal forms. And this is from mathematical logics and this is related to MFCS DMGT. So in this video, I'm going to explain few problems related to PCNF and I'm going to explain the definition of PCNF, that is principal conjunctive normal forms. See, before going into that point, so you have to learn about the max terms, how this max term is related to PCNF. I'll explain you. So max terms. So first of all, we have to take two propositions. The max term consists of disjunction. So disjunction means, so the sum symbol here, the disjunction means or. Disjunction in which each variable or its negation. So if you take two variables P and Q, so it is P and its negation. So negation P, but not both appears. So these two variables should be connected with the disjunction. So then those connected variables are called the max terms. For example, P or Q, P or negation Q, P or negation P or Q, negation P or negation Q. The symbol here is disjunction. So the sum of all the variables and its negations but not both appears are called the max terms. How these max terms are related to the principal conjunctive normal forms? Let's see. So the principal conjunctive normal forms is also very clear here. So this is a principal conjunctive normal forms. So the product of all max terms is called the principal conjunctive normal forms. So we have to make a product for all the max terms. So these are all the max terms. We have to make a product. See here, the product symbol is this one, which is conjunction. So here, if you see the product of all max terms, if you multiply all these max terms, we'll be getting the principal conjunctive normal forms. Such a normal form is also called the product of some canonical form. See here, the product of some canonical form. If you observe this one, these two are the max terms. See, these two are the max terms. So if you make a product, so this product symbol is nothing but the conjunction. See here, this is nothing but the conjunction. So these are max terms. So these are the max terms. So whatever is in between these max terms, we have to call upon this. That is the principal conjunctive normal form. So if there is a disjunction, this will be principal conjunctive normal form. So if it is conjunction, so we have to call principal conjunctive normal form, or else, so this is a product. So as you can see that this symbol is product symbol. And these two are the sum symbols. See, clear? These two are the sum. So here what it is saying, the product of the sum canonical forms. So this is otherwise called as the product of the sum canonical forms. Clear? You got an idea on max terms. So the max terms is nothing but the addition, sum between the variables and its negation. So if you add all these max terms, we'll be getting the principal conjunctive normal forms. So these are the important problems. So definitely sure short questions. Please watch this video till the end so that you will be benefited. So obtain the principal conjunctive normal forms of negation of. See here, negation of, this is P or Q. If you observe properly, this is negation of P or Q. So in this, the process here is, if you send negation inside, so we should use the equivalence formulas. So this is De Morgan's law. According to the De Morgan's law, so if you send the negation inside, what happens? So negation P, the equivalent statement of negation P and or will become and. This is negation Q. And according to our principal conjunctive normal form, so there is a variable P. So what is missing here? Q is missing. Instead of Q, I am writing, see here, I have to add this one Q. For that, this is negation P or F, and next one, this is negation P. Here there is Q. What is missing? P is missing. So this is or, this is again false. So this statement, after using this statement, so what we have to do after using the identity statement, so in place of F I am writing, see here, in place of F I am writing, so what is missing? Q is missing, that is Q and negation Q. Clear? And this one is negation Q, or so in place of F, what is missing? P is missing. So this is P and this is negation P. Clear? And therefore, after this one, so we have to use the distributive law. So here is the distribution. So we have to distribute. So this is a distribution law. So according to our distribution law, so it can be written as negation P or Q, and this is negation P or negation Q, and next one, and so this is negation P or P, and this is negation Q or this is negation P. Clear? See here, anything repetition here? So there is a repetition, that is negation P or negation Q. There is negation P or negation Q. So I can use idempotent law. So after using idempotent law, so this is transformed as, this is negation P or Q, and this is we can write for only one time, negation P or negation Q, and this is P or negation Q. Even I can use a commutative law. So if you observe this one, so what is in between? So in between there is a connection symbol, that is conjunction. So there is a conjunction. So these are all the max terms. So these are all, if you observe, these are all the max terms. So this can be written as, so this is nothing but the principal conjunctive normal form. So this is how we have to use. So whatever it is missing, so we have to add here. So here there is P and Q is missing, so I have added Q here. There is Q here, P is missing, that's why I have added this P here. So this one is P here, and after using the distributive laws and giving to each and every term, so we got the product sum canonical form. So this is nothing but the principal conjunctive normal form. And the next equation here is, so this is also important, and next one we have to obtain the principal conjunctive normal forms for P, negation of P, double implication Q. So here for double implication, what is the formula here? The formula for double implication here is, the equivalent formula for double implication here is P implies Q and Q implies P. So this formula I am going to use here. So after using this formula, this will become, that is negation of, this is P implies Q and this is Q implies P. And next one here is, so for taking an implication, which formula we have to use? So the equivalent formula for P implies Q is nothing but negation P or Q. So negation P or Q, if I apply that formula, this will be negation P or Q, and this is negation Q, or this one is P. Clear? So this negation is for both the values. And again I am going to use the De Morgan's law. So what does this De Morgan's law states? So according to our De Morgan's law, if negation is sent inside, so if this negation is sent inside, this will be negation of negation P or Q, and this and will become or. This is negation of negation Q, or this one is P. So again, if I send this negation inside, this will be negation of negation P and this is negation Q, or if I send this negation inside, this will be negation of negation Q and this is negation P. Clear? So this is a double negation formula. According to our double negation formula, negative into negative positive. So I am clearly writing P and negation Q, or this is double negation. So we can write a single one, that is Q or Q and negation P. So Q and negation P. So in this, if you observe, this is P and negation. So this is P and negation Q, and this is Q and negation Q. So in this, I have to use the distribution law. So here P is distributed. So P is distributed here to this bracket, and this one also, negation Q is also distributed. So I am going to use the distribution law. So according to our distribution law, this will be P and negation Q. See here, P is distributed to Q, that is P or. So this is P or Q, and this is and P or. So this is negation P. Next one, and This is negation Q or Q, and this is negation Q. This one is or negation P. Clear? This is P is distributed to Q, and next one P is distributed to negation P. Negation Q is distributed to Q, and negation Q is distributed to negation P. Here if you see this one, so this symbol is nothing but, so this is nothing but the true statement, and this is also a true statement. So this is true and this is true, and therefore this can be written as P or Q. So this one is P or Q and true, and this is untrue, and this one is negation P. So we can use a commutative law here, negation P or negation Q, and therefore the true statement here, this is P or Q, and what remains here, negation P or this is negation Q. If you see here, so this is again a conjunction, so this is again a conjunction, so these are all the max terms. So these are all the max terms, and therefore, so this form is nothing but principal conjunctive normal form. So this is how we have to bring it to principal conjunctive normal form. First of all, we have to remove this double implication using this equivalent formula. That is, I have used P implies Q and Q implies P. So for implication, there is another formula, that is negation P or Q, and here negation Q or P. And after using the De Morgan's law, after sending negation inside, so this will and will become or. See, clear? So after this one, if I send this negation inside, this will or will become and. So if I send this negation inside, this or will become and. And after negation of negation P, double negation formula, I have used a single P and negation Q, and this is also Q and negation P. And after using this one distributive law, P is distributed to Q as well as P is distributed to, so here P is distributed to Q as well as this is negation P, and Q is distributed to negation Q is distributed to this term and as well as that term. And after using distribution law, and this is nothing but the true statement, this is also a true statement, and therefore finally we got this is a conjunction and these two are the max terms. Therefore this is the product sum canonical for variables, and this is nothing but PCNF, that is principal conjunctive normal form. And the next question here is, see here, this one, obtain the principal conjunctive normal forms for principal conjunctive normal forms for negation P implies R and negation P or negation Q. There are two formulas related to this. So equivalent formulas for P implies Q is equivalent to, this can be written as negation P or Q, and for this one P double implies Q, the equivalent formula is P implies Q, and next one this is Q implies P. So both, there is a double implication and there is a single implication here, and therefore I am using both the formulas, equivalent formulas, as see here. For this I am using, for this one this can be written as negation of, see here I am using this formula, negation P or Q. Therefore negation, already there is negation P or R, and see here for double implication there is a formula P implies Q, that is here Q implies P, and here this is P implies Q. So again there is an implication symbol here. So for implication there is an equivalent formula, that is negation P or Q, and there is a double implication formula here. For double implication, what is the double implication? So negation of negation, this is P or R, and so for this is negation Q or P, and this is negation P or Q. Clear? And therefore this can be written as negation P. So this is P or R, and this is negation Q or P, and this is negation P or Q. See here, there are three variables here, that is P, Q and R. So here P and R is there. So what is missing here? So here the missing term is Q, and therefore I am adding F here, that is a false statement. And next thing here is, in this statement, that is here if I write properly, this is P or negation Q or, so here R is missing, so I am adding this statement false, and next one, and So this is negation P or Q or. So here again R is missing. So I am writing a false statement. I'm writing a false statement for this. So whatever it is missing, so we have to add the term, that is P or R or. So here P R are there. So what is missing? Q is missing, that is Q and negation Q. In place of F I'm using this one, P and negation Q, and here this is P or negation Q or. So here what is missing? R is missing. So in place of R I am writing R and negation R. Clear? And next one, this is negation P or Q or. So in place of F, what is missing? R is missing, that is R and negation R. R and negation R. So this is R and negation R. And therefore, if you see properly, so whatever there is, so we have to use the distributive law. So here each and every term is distributed. So P is distributed and here R is also distributed. So here this one, so P is distributed and R is also distributed. So I am using the distributive law here. So each and everything is multiplied. So if I multiply this one, so this will be distribution law I am using. So this will be P or, see here, this will be P or Q. So this is P or. So if I set this as one bracket, if I set this as one bracket and set this as one bracket, this will be P or R or Q, and there is a symbol and here this is P or this is negation Q, and this is P or negation Q or R, and here there is un symbol here, and again this one is distributed P or negation Q or, this is negation or, and there is un symbol here, and this is negation P or Q and or R. Clear? And un symbol here, this is again negation P or Q or, this is negation R. Clear? And if I write P Q R in a proper order, and this will be P or, this is Q or R, and next one, so if I write P Q R in a sequence, that is P or negation Q or R, and here this one in this, that is P or negation Q or R, and this one, this is P or negation Q or negation R, and this is negation P or Q or R, and this is negation P or Q or, this is negation R. And see, if you observe, these are all the conjunctions. So these are all the products or conjunctions. So these are all the conjunctions. And if you observe, so these are all the max terms. The max terms means the sum of the variables and its negations. So these are all the max terms. So these are all the max terms, and this is nothing but the conjunction. So if you observe, so this is in the form of principal conjunctive normal form. So this whole statement, it was brought into the principal conjunctive normal form. If you see, so this is the statement given. So there is a double implication and single implication also. Using an equivalent formulas for double implication, this is P implies Q and Q implies P. And here for single implication, there is a formula that is negation P or Q. So if I apply both the formulas here, and see, again there is an implication, negation of negation P or R. And here also the same formula for implication I have used, that is negation Q or P and negation P or Q. And see, here if I write it properly, and if I have to add, so whatever it is missing, there is P and R and Q is missing here. P and Q are there, R is missing here. P and Q are there, R is missing here. So I have added up this R here, Q here, R here and R here. And after using the distribution law, and therefore we got the final statement here, or all the conjunctions in between, whatever it is. If it is conjunction, you have to write as principal conjunctive normal form. If in between there is a disjunction, we have to write it as principal disjunctive normal form. So in our case, there is a conjunction, and these are all the max terms. In between, they are all the max terms. Therefore, this is principal conjunctive normal form. And the next question here is, so next one, third one, it is missing, I think. So third one, so this one is missing. So the first one I have given a solution for the first thing. So this one is given a solution. And the next one here is double implication, also have given a solution. And next one here is P negation P or Q. So this one is also solved. And what is missing here? Negation of, see this one is second one is missing here. So let me solve this one. That is the second question, that is negation of this one is P implies Q. So we have to obtain the PCNF. The PCNF means principal conjunctive normal form. So here this will be, after taking implication symbol, this will be negation P or Q. So if I send this negation inside using De Morgan's law, so this is negation of negation P and or will become and this is negation Q. So double negation, it is nothing but P and negation Q. So this is nothing but P and negation Q. So in this, so here there is P here. So what is missing? So I have to add this one. So here Q is there and what is missing? P is missing. So instead of adding P, I have taken this false statement and therefore I can write in place of F as, that is P or. So Q is missing, therefore I am going to write as Q and this is negation Q in place. So next one, this is negation Q or. In place of F I am writing P, that is P and negation P. So according to our negation law. And after that one, so we have to use the distribution law. So here P is distributed to Q as well as this one, and negation Q is distributed to both these. This is a distribution law. This one is negation. Negation law, here it is a double negation. Double negation law. See, there are equivalence formula given in my previous videos. Please go through. There are only 10 formulae. So easily you can catch up. So this one is implication formula and this one is De Morgan's law. So this is De Morgan's law. All the formulas are ready here for you. So there are only 10. Please go through and this will be very easy. So here P is distributed. Therefore, this can be written as P or Q. And there is an and symbol here and this is P or negation Q. And symbol here, this is negation Q or P, and symbol here, and this is negation Q or negation P. If you observe carefully, so what are these symbols? So these symbols are nothing but, so these are nothing but the conjunctions. So these are nothing but the conjunctions and these are all the max terms. So these are all the max terms and therefore here the product of some variables is called the PCNF. The PCNF means the principal conjunctive normal forms. So I have given solutions for all the important questions here and I have explained you clearly. So I have in my previous video there will be equivalent formulas which will be very helpful for solving these problems. Please go through those previous videos also. There is a playlist ready for you and I have uploaded all my videos there and it will be very helpful for your preparation and you can score more. And please go through these videos and pass it on to your friends and siblings and whomever you like the most, and subscribe to this channel and stay connected, and I'll be uploading some more videos which are related to this DMS. Thank you so much for watching and staying till the end.